Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4. And then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got times the top by 4 as well, to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it'd be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 3/20. And we can add the 4 and the 1 together to make 5 3/20. So the answer is 5 3/20. The formula y equals mx plus c includes this m, and the m means the gradient. So if we're looking for something that is parallel to y equals 9x plus 18, we're looking at this number here. And for it to be parallel, it needs to have the same gradient. So we could just write y equals 9x plus or subtract anything. Or we could just write y equals 9x. I'm going to say plus 5. So when we say y is directly proportional to x, what we mean is whenever x doubles, y will double. Whenever x halves, y will halve. Now, we've got this proportionality sign here. And to make that an equals, all we need to do is introduce a k constant to the right-hand side. So it's y equals something times x. Now to find out what that something is, to find out what that constant is, what we're going to do is feed in the value of y and the value of x that we have. So we're going to feed those in. So y is 55.3 and x is 7. So it would be 7k. And we're just going to put our lines in and solve this. So it's going to be divide by 7 both sides. And 55.3 divided by 7 is 7.9. And that's what k is. So we're going to rewrite this equation here, this formula here, y equals 7.9x. And that is actually our answer. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually times it by not 1,000, but 1,000 squared, so that's another 3 zeros. You can see here that that's a million, so we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by a million. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over. And how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19. But it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So we're going to start by understanding that all lines form or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31 and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18 and the x value is the w value. So w is 18. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question. So what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got 2 sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason. so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So here we're asked to find how many bread rolls we can make. We've got 89 kilograms and it takes 0.08 kilograms to make a bread roll. Something we can do is convert these into grams, or we can just keep it at kilograms, but I've got a neat little trick. And the trick is, if you've got a decimal when you're dividing, as long as you do the same thing left and right, you can multiply them by 10 or 100. In this case, we're going to multiply both by 100 because it will make the division a lot easier, because it will make this right hand side, instead of 0.08, it will just make it 8. The reason we can do that is 89 divided by is the same as 89 over 0.08. And as a fraction, we can just times top and bottom by 100. So it would be this over 8. So now we can do the bus stop method. So 8 on the outside. And in fact, I might use a straighter line here. There we are. And we've got 8,900 on the inside. So 8 into 8 go 1, 8 into 9 go 1, remainder 1, 8 into 10 go 2, remainder 2, and 8 into 20 go 2, remainder 4, and 8 into 40 go 5. Now it says how many bread rolls can we make. Now we can make 1,122 and a half. Well, half doesn't really count, so we're just going to say 1,122 whole bread rolls. Yes, we've got half a bread roll left over, but we are asked how many whole bread rolls can we make. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So W therefore equals 4. Now between A and B, the shapes haven't changed size, so it's not an enlargement. They haven't rotated or they haven't mirrored, they've just moved. And the word we use for that is translation. So this has been a translation. And for a translation, we need to find out how far right they've gone and how far up they've gone. So we pick a point that we know on both shapes, and I'm going to pick the top left. And we count how many jumps we jump to the right. So 1, 2, 3. So we do 3 jumps to line it up with the other one. So there's a 3 at the top, to say 3 to the right. And then we count how far up we have to go. So 1, 2, 3, 4. Now we've actually had to go down, and whenever you go down, it's like having minus up. Okay, down is minus up, so it's going to be minus 4 because there were 4 jumps. There is quite an easy way of doing this question, but I'm going to show you the long way and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. So we're going to write an expression for the amount of people on the first bus. So they've started with X passengers and they've gone to 11 bus stops with X passengers. So altogether that is 12X. So we're going to have the first bus, and so we've got 12X, and then on the last bus stop 19 passengers get on, so plus 19. Now for the second bus, well, we start with X and a further 5X come on, because 5 bus stops with X passengers, so that's 6X altogether, and then 79 get on. And it says the first bus finishes with less passengers than the first. So the first bus finishes with less, and the way we show that is with this inequality here. Now all we need to do is solve that inequality, and we've got X on both sides, so we look at the X's. We've got 12X and 6X, so we always take away the smaller amount, so we're going to take away the 6X both sides. And next thing we're going to do is take away the 19 from both sides. And so, meant to be 60. Got ahead of myself. And the last thing we do is divide by 6 both sides. And so we've got X is less than 10. Now, it says here, assuming no passengers got off either bus, what is the largest value for X? Now it is tempting to write down 10, but it says X has to be less than 10. So the biggest number we can get that is less than 10 is 9. So for this question, what we need to do is factorise 4t plus 6. Now factorise means put it into brackets. So if I try, what I can do is I can actually put a 1 on the outside here. So 1 times 4t plus 6 is 4t plus 6, but the question clearly states that it is higher than 1. So we need to find another number that's higher than 1 to factorise this with. So if we look at 4t and 6, well, they're both in the 2 times table. So I can put a 2 on the outside here. 2 times 2t is 4t, and 2 times 3 is 6. So what we can do is we can just check that out with smiles and rainbows. Put all my times down there to remind me to times it. So 2 times 2t is 4t, 2 times 3 is 6. So that works because that is the same as this in the question. So we know that 2 times 2t plus 3 works. In fact, it's the only one that works with it being an integer. So we therefore know that the known side, because it says it's a known number, is 2, and the other side will be 2t plus 3. And then when you multiply them together, you get the area of 4t plus 6. So our answer, because it says the length is the known number, so that's the length, then we're finding the width, which is this one here. So it's 2t plus 3. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120, and we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So I'm going to write this question out a bit bigger, just so we've got a bit more room. And we're asked to solve. So what we're going to do with this is we're actually going to start by putting our solving lines in, and we're going to try and figure out what we do to get x on its own. So we're going to start by subtracting 9 to both sides. And so that will leave us with the 10x squared on the left hand side and then 250 on the right. Then we're going to divide by 10 both sides. So we've got x squared equals 25. And then we're going to square root both sides. Now, this does give us 5, but it also gives us -5, because minus 5 times minus 5 is also 25. So our two solutions are 5 and -5. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power 16 times 9 to the power 46. Now, when you have two powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between two powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40. We just take away the indices. So it would be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. Sometimes it's easier with these questions to multiply both numbers by, say, 10 or 100 or 1,000. So if we look at the 0.06, if we times that by 100, it would make the question a lot easier. But with a division, if you times one of the numbers by 100, you have to times the other one by 100. So we just go times the 30 by 100 and times the 0.06 by 100 to make that 0.6. And this actually is the same calculation as 30 divided by 0.06. The reason being is that you can write that as a fraction. And you know with fractions you can just times the top by something and times the bottom by something. It doesn't change the fraction at all. It just keeps it exactly the same. So we're going to use the bus stop method to find out what that is. So we're going to divide that out. 6 doesn't go into 3, so carry that. 6 is into 30, go 5, 6 into 0, 6 into 0, so that's going to be 500. So I'm just going to write this out a little bit bigger, just so we've got a bit more room to play with. And I'm going to start by putting my tramlines in. Anytime it says solve, I always put my tramlines in. We can start by either multiplying out the bracket, or we can be clever and just divide by 5 both sides. And that'll leave 6x minus 39, and 15 divided by 5 is 3. Then I'm going to add the 39 to both sides. And so we've got 6x is greater than or equal to 39 plus 3, which would be 42. And then we're going to divide by 6 both sides. And we've got x is greater than or equal to 7. So we can write this as a fraction. So it would be 2.84 times 10 to the power of 11 over 4 times 10 to the power of minus 2. What we can do is split this up into two fractions. So 2.84 over 4 times 10 to the power 11 over 10 to the power of 2, or minus 2. Okay, so we're going to start by doing 2.84 divided by 4. So we're going to just do the bus stop method. So 4 on the outside, and we've got 2.84 on the inside. 4's into 2 don't go, so carry the 2 across. 4's into 28 go 7, and 4's into 4 go 1. So it's going to be 0.71 times, and then the rules of indices say that if you divide two powers of the same base, they're both 10, then you just take away the power. So it's 11 take away minus 2. Now the two minuses, the two takeaways, actually convert to a plus, so it would be 11 plus 2, which would be 13, so it would be 10 to the power of 13. Now we've got a bit of a problem here, because standard form must have a number between 1 and 10, and not including 10, at this position here, and this is obviously less than 1, so we need to convert this into standard form. So what we can do is just write the number out again. So I'm going to write this as an actual number. So it's 10 to the power of 13, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Fill in the zeros. So it'd be 7, 1, and all those zeros. And then I'm going to put it back into standard form. Now, the decimal point will need to be here to make it 7.1. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7.1 times 10 to the power of 12. Now, with a bit of practice, you don't need to write out the whole number. You'll be able to just know that if you convert that into 7.1, then you just need to take away 1 from the power. But if you're not sure, and it's not an unreasonable number like 10 to the power of 105, then it's just worth sometimes just writing out the actual number and being 100% sure that you've got it the right way around. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power of 4, w to the power of 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power of 4, w to the power of 5. Some people will try and do something with the v to the power of 4, w to the power of 5. But if you think about it, if I just draw out my square, if it's 11v to the power of 4, w to the power of 5 all the way around, when you add, you don't add the v to the power of 4, w to the power of 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power of 4, w to the power of 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power of 4, w to the power of 5, and we're going to just times it by itself, which is what squaring means. Okay, So we're going to times the 11s together, so that's going to be 121. Going to times the v to the power of 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power of 5s together, so that makes 10. So it's 121, v to the power of 8, w to the power of 10. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. In this question we have a right angle triangle, and we know two of the sides and we're looking for the third one. So that screams to me Pythagoras. So Pythagoras is a squared plus b squared equals c squared, with c squared being the hypotenuse. The hypotenuse is the one opposite the right angle, so this is going to be c. And we'll label the other ones a and b, it doesn't matter which way around they go. So a is 5, so it'd be 5 squared plus 12 squared equals c squared. 5 squared is 25, 12 squared is 144. And so 25 plus 144 is 169. Now that's c squared, so we need to solve here, and the way to solve is just to square root both sides. And so it would be 13 equals c. Because it's distance, we don't worry about the negative 13, so just the positive 13. So we know c is 13, so we need to know what the total length around the triangle is. So we're going to add the 5, the 12 and the 13 we've just found. When you do that you get 30. So we know there's 30 meters in total. Now it does say that we need 90 milliliters of paint per meter of wood. So the amount of paint needed is going to be the 30, because that's the total distance, times the 90, because we need 90 for every meter of paint. 3 times 9 is 27, and then put the 2 zeros at the end. So the answer is 2,700 milliliters. So we've got to first of all understand what standard form is, and standard form is a number that is between 1 and 10, but not including 10, times 10 to the power of another number. So to find out what the numbers are going to be for our standard form, we're going to just write down the decimal first, so 0.098. And we've got to put a decimal point in somewhere to make this a number between 1 and 10. So if I put it in here, that would make it 9.8, and we're ignoring the zeros to the left-hand side. So we know that our standard form is going to start off with 9.8 times 10 to the power of something. Now this times 10 is always going to be there. It's never divided by 10 or anything like that. It's always times 10. Next, we've got to find out what the power is going to be. So first of all, if it's a small number, if it's a number less than 1, which this is, it's a small number, it's going to be a negative power. And the next thing we do is work out how many jumps we had to do. So it would be 1, 2 jumps between where the decimal point was and where it is now. So 2 jumps means it's going to be to the power of minus 2. So we're going to start by doing a grid, a multiplication grid, and we're going to start by putting 2x plus 11 at the top and 5x plus 3 down the side. And we're going to multiply them out, so 5 times 2 is 10, so it would be 10x squared. 5x times 11, so 5 times 11 is 55, so that'd be 55x, and it's positive. And 3 times 2 is 6, so that'd be 6x, and that's positive. And 3 times 11 is 33, and that'd be a positive. So when we put them all together, we get 10x squared plus 55x plus 6x plus 33. You can see that the x terms are like terms, so we can add them together. So we get 10x squared plus 61x plus 33. So our answer will be 10x squared plus 61x plus 33. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. So to answer this question, you need to just know the answer off by heart. There is a diagram that can help us actually get there. And if we just draw a right angle triangle and put the lengths as 1, not right angle here, we can use Pythagoras, a squared plus b squared equals c squared, to work out the fact that this is going to be root 2. Because it's an isosceles triangle, this angle here is going to be 45 degrees, and same with the bottom right one, but we're not interested in that. When we label it with our marked angle here, we've got the adjacent is here, and the hypotenuse is here. Now we know from trigonometry that cos x equals a over h. The angle is going to be cos 45, and a is going to be 1, and h is going to be root 2. Now, this is a bit of a strange one with 1 over root 2, because we need to actually be able to rationalise the denominator. And basically what that means, if you haven't done surds yet, or you aren't doing surds, is you times tom 1 by root 2. And so we end up with root 2 over 2. So if you ever see 1 over root 2 is absolutely fine as an answer, but if you ever see the answer as root 2 over 2, the two are actually exactly the same. So writing 1 over root 2 is fine, or writing root 2 over 2 is also correct. So the first thing we notice is the coefficients of the x's and the coefficients of the y's are different, but if we look at the y's, they are very similar. So we've got 3y and we've got 6y. So all we need to do is times everything in the top equation by 2, and then they'll be matching. So we're going to write out the first equation again. And what we're going to do is we're going to multiply everything in it by 2. And so I'm going to write that equation again, just so we can match up the equations nicely to be able to do our simultaneous equations. And I'm going to write the second equation just as it is, because it's already 6y. And get my bubbles in, because obviously we're working downwards. Now we're either going to be adding or subtracting these, and the way of telling is looking at the sign before the 6y's, the matching coefficient, and if they're the same, then we subtract. If they are different, then we add. Now these are both the same, they're both positives, so we are going to be subtracting. So we're going to subtract the top ones from the bottom ones. 10x take away 6x is going to be 4x. 6y take away 6y is nothing, which is good, because if we're left with any y's here, that means we've made a mistake. And 70 take away 54 is 16. And let's get our lines in, because we need to solve this last bit by dividing 4 both sides. And so we've got x equal to 4. Now that's only half the job, because we need to find out what y is. So what I'm going to do is just copy this first equation, but substitute in the value of x, which is 4. So 5 times 4 plus 3y equals 35. Get my lines in. And 5 times 4 is 20, so I'm going to take away 20 both sides to get rid of the 20. So we've got 3y equals 15. And then we're going to divide by 3 both sides. So we've got y equals 5. Now we can substitute in the values into the second equation. So 6 times 4 plus 6 times 5 does equal 54. When solving simultaneous equations graphically, if you draw the lines to both graphs, which we have done here, the solutions, or solution, because they're both linear, will just be where the two graphs cross. So this here will be our solution. So x is 2 and y is minus 4. First things we notice with the simultaneous equations is that the coefficients of the x and the y are different. And so we're going to just focus on the y's. We've got a 3 and we've got a 5. So we've got to make them the same. So we're going to look for the lowest common multiple. So 3 and 5 is going to be 15. And we could have looked at the x's, but I always look at the y's. So we're going to make the coefficients of the x both 15. So let's write out the first one, get our lines in. And to do that, we're going to times everything by 5. So it's going to be 10x plus 15y, which is good, that's what we wanted. And then 16 times 5, which is 80. Do the same with the next one. So we're just going to copy out the equation, get our lines in, and we're going to times everything by 3 this time to make the y coefficient 15. So we've got 3x times 3, which is 9x, 15y on the next one, and then 25.5 times 3, which is what, 76.5. And we're going to write out the two equations we've just worked out again, but this time next to each other, so we can do our simultaneous equation magic on them. So we're going to do our circles first, and simultaneous equations are all about going downwards. So we're just showing what we're doing. We're going to either add or subtract each of these. Now, to find out whether we're going to add or subtract, we look at the signs of the y's. If they are both the same, we are going to subtract. If they are both different, then we're going to add. So S in same, S in subtract. The D in different is the D in add. Now looking at them both, they are both the same sign. They're both plus. They're both positive. So we're going to subtract. But we're not just going to subtract those. We're going to subtract all 3 of our circles. So we're going to put our line in here. And we're going to do 10x take away 9x, which is just x. 15y take away 15y, which is nothing, which is good, that's what we want. And then we're going to do 80 take away 76.5, which is 3.5. And here we're left with x equals 3.5, which is brilliant. But that's only half the job, because we've then got to work out what y is. So I'm going to substitute x into this first equation here. So we're going to do 2 times 3.5 plus 3y equals 16, and we're going to get our lines in. And the first thing I'm going to do is 2 times 3.5, which is 7, so we're going to subtract 7 from both sides. And we've got 3y equals 16 take away 7, which is 9. and then we're going to divide by 3 both sides to get what y is. And so 9 divided by 3, which is 3. Now we can check this by substituting that in to our second equation and see whether it equals 25.5, which it does. A box plot starts with the lowest value, then it goes to the lower quartile. So we have the lowest value, then the lower quartile, and then we have the median, then the upper quartile, and then the highest value. So lowest value is at 1 on this one, and normally we just put a little kind of line at the end here. So we're going to put a line at 1, and I'm just going to put that line there. Ooh, a little bit further to the right. There we go. And our lower quartile is 9, which is kind of where the box starts. So we're just going to start a box there. We're just going to connect these up. There we go. And our median is 11, so we're just going to show that. Quite a thin box plot so far. Now it says the interquartile range is 5. Now the interquartile range is the distance here. So that's 5. So it's going to be 5 more than the lower quartile. If the lower quartile is at 9, it would be 9 plus 5, which will be 14. So if we get our line at 14, and then complete our box plot. Here we go. Now the range is the total distance of, or the total width of our box plot. So that's 17. So that's going to be 17 higher than the lowest value. Now the lowest value is 1, so 1 plus 17 is going to be 18. So I'm just going to, there we are. And we're going to have that at 18. And again, I'm just going to put a line there. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17, so we're just going to draw a line at 17. Get it just perfect, there we are. Okay, next thing, we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile. And we do that by adding the 5 and the 10 together to make 15. So we'll draw a line across from 15 and down. And that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. We're going to first of all get x equal to the 0.151151, blah blah blah. And what we need to do is we need to pull all of the recurring numbers in front of the decimal point, or at least one instance of them. So I need to times it by 1,000. So we're going to do that. Times it by 1,000. And we'll get 151.151.151, blah blah blah. What we're going to do now is we're going to subtract going downwards. So 1000x take away x would be 999x, and then 151.151.151, etc. Take away 0.151151 etc. will just be 151. Get our solving lines in, because the next thing we're going to do is divide both sides by 999. And so we end up with x equals 151 divided by 999, or over 999. And that's our answer. So we're going to first of all factorise the quadratic, and we'll end up with 2 brackets equals 0. And to do that, what we want to do is multiply the coefficient of the x squared and the number unknown together. So we're going to do 12 times the 6, which is 72. So we need 2 numbers that times together to make that 72. And we're also going to look at the coefficient of the x, minus 17. So we need 2 numbers that add together to make that minus 17. They need to be the same 2 numbers. So what we can do is we can write out the factors of 72 and try and find them. We can kind of use our head. So it's going to be minus 8 and minus 9. I knew they both need to be negative because they add together to make a positive. Sorry, they add together to make a negative and they multiply together to make a positive. And then just trial and error, just think it through and get minus 8 and minus 9. So we're going to rewrite the expression on the left, but instead of minus 17, we're going to write minus 9x minus 8x, or whichever way around. So we're going to do 12x squared minus 9x minus 8x. I could have done it the other way around. Plus 6. We're going to factorise linearly the first 2 terms, and we're going to factorise linearly the second 2 terms. So here we can actually divide out 3x from both of them. And we always put the minus on the outside, so it would be minus 2, and that would be 4x minus 3. The repeating bracket is our second bracket, so 4x minus 3, and then the bit on the outside, 3x minus 2, becomes our first bracket, like so. So let's put that back into our equation, and to solve this now, you get both of the brackets equal to 0. So we're going to get this equal to 0, and get our solving lines in. So we're going to add 2 to both sides. Oh, right, 3 there. Add 2 to both sides. And so we've got 3x equals 2. Then we're going to divide by 3 both sides. And we get x equals, and you can write this any way you want, but I'd write this as a fraction to keep the accuracy up. So our first solution is 2/3. And we're going to do exactly the same thing to the right hand side. Get it equal to 0. Get our solving lines in. And we're going to add 3 to both sides. So we get 4x equals 3. And again, divide by 4 both sides. And we get x equals 3 over 4. So our second solution is 3/4. So looking at the graph straight away, we know that the y-coordinate of point A is 0. And we're told that it's y equals tan x. And you just need to know the graph y equals tan x. And if you know the graph, we know that that will be 180 degrees. We know the point at which both of these lines will be going towards would be 90. This point here will be 270. And so therefore this point will be 360 degrees. So it's going to be 360, 0. The first thing to notice is that 125 is 5 cubed. So instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. When asked to simplify a fraction, we need to find a factor at the top and the bottom of the fraction to divide out. So we're going to start by factorising these fractions, and I'm not going to go into how to factorise quadratics. because we've got plenty of other videos on the site that go into that. But when you factorise the top, you get 3x plus 4 and x minus 5. And when you factorise the bottom, you get 2x minus 1 and x minus 5. Now, it's not a coincidence we have the x minus 5 at the top and the x minus 5 at the bottom, because we're just going to divide that out to simplify the fraction. So we're just going to divide that out. That will make that convert it into 1, and 3x plus 4 times 1 is just 3x plus 4, and same with the bottom. So we end up with 3x plus 4 at the top and 2x minus 1 at the bottom. I'm going to start by getting x equal to the 0.847 recurring, and I'm just going to show that with 3 dots. And we want to bring forward everything that's not part of the recurring pattern. So what I'm going to do is I'm going to find out what 10x is, and that's going to be 8.4747. So what I've done is I've just got the recurring pattern after the decimal point. And what I want to do now is bring forward one of the occurrences of the recurring pattern, so the 4 and the 7, just one of them. So we're going to times it by 1,000. We'll find out 1,000x, and so it would be 847.4747, etc., etc. Next, I'm going to take away everything. So 1,000x take away 10x, and that's going to be 990x. And then 847.4747, etc. Take away 8.4747, etc. It's just going to be the same as 847 take away 8, because the recurring stuff will just cancel each other out. So 847 take away 8 is 839. And now I'm just going to put my lines in. And so what I'm going to do now is just divide both sides by 990. And so on the left hand side we've got x, and on the right hand side we have 839 divided by or over 990. So as a fraction it's going to be 839 over 990. So if we have x equals the 0.098 9898 blah blah blah, we actually want the repeating pattern to be next to the decimal point. So we're actually more interested in 10x, and so that'd be 0.9898 blah 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 blah. And we want the repeating pattern to also be in front of the decimal point, so just the digits that repeat. So if we did 100x, it would just be the 9, so we need to do 1000x. And that will give us 98.9898 blah 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 blah. And we can see here, if we subtract these now, so we subtract the left and the right hand side. On the left hand side, 1000x take away 10x would be 990x. And on the right hand side, we're actually just going to get rid of the repeating pattern, so that would just equal 98. And then we want to solve, so we're going to divide both sides by 990. And divide just means over, so we can just write it as a fraction. Now they are both even, so chances are, well, they will definitely divide by 2. And so we divide top and bottom by 2, and we get 49 over 495. So for this question, first thing to notice is there's a divide there, and we can actually just write this as a fraction. So 10 plus root 2 over 14 plus root 2. I'm going to keep the brackets there. We don't need them when it's in a fraction, but it will help us for the next step. So we're asked to transport this or change this into a fraction without a surd at the bottom. And so it's basically asking us to rationalise the denominator. Now, when you have two terms, including a surd at the bottom, we need to do something a bit special with this. And the thing we do is we times it by the opposite bracket. And what I mean by that is if it's 14 plus root 2, we times it by 14 minus root 2. And we've got to do the same to the top. And the reason for that is essentially here all we're doing is we're timesing it by 1, because 14 minus root 2 over 14 minus root 2 is just 1. So we're timesing it by 1, so we're not changing the fraction at all. Okay, let's draw a grid to work out what that will equal. And you can use any method you want. You can use double smiles and rainbows, FOIL, whatever method you have to multiply two such brackets. I'm going to start off with the top. The top is 10 plus root 2 times 14 minus root 2. So 14 times 10 is 140. 14 times root 2 is just 14 root 2. 10 times minus root 2 is minus 10 root 2. And then a minus and a positive make a minus, and root 2 times root 2 is just 2. Now, when you expand Surdy brackets, these two and these two will add together. Okay, so we're going to start off with the numbers. 140 take away 2 is 138. And then we'll do the surd. So 14 root 2 take away 10 root 2 is plus 4 root 2. Okay, so the top is going to be 138 plus 4 root 2. And let's do the bottom. And I like these grids because you can see if you've made any mistakes quite quickly with these. You can check your working. So 14 plus root 2 times 14 minus root 2. You'll see why in a second we do the opposite. So 14 times 14 is 196. 14 root 2 minus 14 root 2 and then minus 2. So you can see here now there's a 14 root 2 plus minus a 14 root 2. Let's just cancel each other out to 0. So we get rid of the surd. And then 196 take away 2, which is 194. So we've got 194 at the bottom. Now something we notice here is that all the terms in the fraction are even, therefore we can halve everything. So 138 halved is 69, 4 root 2 halved is 2 root 2, and 194 halved is 97. And so that would be 69 there, and that would be 2, and then that would be 97. So we're going to just quickly write out our sequence, so 9, 22, 41, 66 and 97, and we're going to find the differences of each of them. So that's going to be plus 13, then we've got plus 19, so they're different already. We know that it's not a linear sequence, and that's going to be plus 31. So we now look at the difference of the differences, and so we've got plus 6 again, and plus 6 again. When you have a difference of differences, it's going to be a quadratic sequence, and we're interested in what the difference of differences is, because what we now do is get that 6 and we always halve it, and it gives us 3. Now that 3 is actually really important because that is the coefficient of the n squared, so we know our sequence will begin 3n squared. So we're going to do a table now to see what the rest of the sequence will be. And we're going to have our term number and our sequence. So term numbers will just be first, second, third, fourth and fifth. So 1, 2, 3, 4, 5. The sequence is just 9, 22, 41, 66 and 97. Now we know that 3n squared is part of our sequence. So what we're doing now is just removing the 3n squared bit and see what we have left over. So we're going to do 3 times 1 squared, which will be 3, 3 times 2 squared, which will be 12, and then 3 times 3 squared, 27, 3 times 4 squared, 48, 3 times 5 squared, 75. And we're just going to remove that from our sequence. So we've got our sequence, and we're removing the 3n squared bit because we know what that is. We've already answered that part. So 9 take away 3 is 6. 22 take away 12 is 10. So they're not the same with this. 14, 18, 22. Now what do you notice? Well, we notice that these ones here are going up in 4s. So we've got a linear sequence here. So they're going up in 4s. So we know that that will be plus 4n. And then we find the 0th term. So we go back. So 6 take away 4, which will be 2. So it's going to be 4n plus 2. So our total quadratic sequence will be 3n squared plus 4n plus 2. So a tan graph, a normal tan graph, starts at 0, 0 and goes up to, I'm going to call it positive infinity. It's not quite right, but you get my point. It goes up very, very high there at 90 and then starts down here just after 90 and then goes to 0 at 180. But here we're told that we're going to add 1 to it. So each of the points we're going to add 1. Now it actually might help us to know that there is another point here. Tan 45 is 1, so actually that might help us here. And so tan 135 is actually minus 1. So this will give us a little bit of a hint about how to go about doing this. So all we're just going to do is move all the coordinates up by 1. And then we try and draw that out. Now this first bit's going to be fine because it's just a curve going upwards. This is going to be slightly more difficult because we're kind of guessing somewhere around there. And it's going to go back to 180 there. You can see that there's a negative on the outside of the function, and when we have a negative on the outside of the function, it means that we reflect it in the x-axis. So we're going to be reflecting this graph in the x-axis. We can see it crosses the x-axis here, so our graph needs to go through that point, and we just try our best to reflect it, and so it should look something like this. And we're going through that point there and then all the way up. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.